Hello, everybody. This is Mr. Walker. Our topic today is using multiplication to solve division problems, but today's focus is going to be problems that have remainders. By the end of this video, you will be able to use multiplication facts to solve problems like these that have remainders. 37 divided by 9. I'm going to use our division fact to write a multiplication fact. 9 times n, which is our unknown number, is equal to 37. I know that 9 times 1, 2, 3, 4 is equal to 36, but we do not have anything, if you look on our multiplication chart here, that is 37. The closest we can get without going over would be 36. So that would be 9 times 1, 2, 3, 4. So n would be 4, but notice that it does not equal 37, so I'm going to scratch that. It actually equals 36. I'm going to use both of those numbers. The 4 goes on top for our quotient. The 36 is going to come down here. We notice that it does not equal 37. It's close. How close? Well, we subtract. 7 take away 6 is 1. So the answer is 4 with a remainder of 1. So we would read this problem as 37 divided by 9 is equal to 4 with a remainder of 1. You may remember on a previous video that we did a similar problem, 36 divided by 9. This was 37 divided by 9. And we wrote a multiplication sentence and determined that 9 times 4 was equal to 36. In that example, when we put the 36 down here, you'll notice that that was the same and we had no remainders. So sometimes when you divide, you have problems that have no remainders, but sometimes you have problems like this one that do have remainders. Remember some vocabulary. For this lesson, we are using long division symbols. Sometimes they're referred to as division brackets. I like to call them a division box, and sometimes they'll look like this with this curve. Our vocabulary, the large number that we start with is called the dividend. The number of equal groups that we're looking for, in this case it would be 9, is called the divisor, and that the answer, in this case 4 with a remainder of 1, is referred to as the quotient. And that's probably the one that we're going to focus on more in the next few lessons. And you would read this problem starting with your dividend and kind of go in a clockwise motion. You would read this as 37 divided by 9 is equal to 4 with a remainder of 1. So in other words, 37, or saying it again, 37 divided by 9 equals 4 with a remainder of 1. Some important ideas, some key ideas for division is that we are dividing into equal groups, or the concept of fair share, that every individual or every section or every part has a fair share. But sometimes there are some that are left over, and we call these remainders. So for example, here's a way to model some problems side by side. Similar problems, 12 divided by 3, this one is 13 divided by 3. This is an example with a remainder, without a remainder, and this is an example with remainder. 12 divided by 3. Notice that we have our 12, 1, 2, 3, 4, and if you count that, that's 12. If I want to make 3 equal groups, which I can do like this, So 1, 2, 3, that is our divisor 3. And if you look, we have 1, 2, 3, 4 in each of these groups. This is a similar example, but instead of 12, notice that it's 13. Our dividend is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Our divisor is once again 3. Remember the concept of having equal groups. These are equal, but notice I cannot create another equal group. I have one that is left over. That's called your remainder. So our answer for this would be each of these groups have 4. The top one has 4, the middle and the bottom have 4, but there is this one left over. That's called our remainder. So that's why we would say 4 with a remainder of 1. Again, keep in mind place value. The rules of place value still apply. For example, our dividend of 12, the 2 is in the ones and the 1 is in the 10. So 12 divided by 3. When we put our 4, you want to get in the habit of putting the 4 in the appropriate place value. 4 is a 1-digit, right? So that would be 4 ones. And that's why it would go. Again, it's not a hard, fast rule, but it will be helpful when we get to harder problems moving forward. Using multiplication is our focus today to solve division. Remember, there's something called inverse operations, also called fact families. For example, 8 times 3 equals 24. Or you could switch the 8 and the 3 and say 3 times 8 equals 24. That's your multiplication. But you can use the same set of numbers to do division. 24 divided by 8 equals 3, or 24 divided by 3 equals 8. Notice in all of these, we're using the same 3 numbers. Let's do an example with no remainders. And I wrote the word cookies here to remind myself to think, a lot of times when you do division, try to think of this dividend as if you had cookies. And you say, what do you mean? Well, 24 cookies divided by 3 people. It kind of brings it to life and helps you understand it a little bit better. Okay, 24 divided by 3. Remember, we are going to use multiplication. All right, let's see if we can figure this out. The 3, this gets a little bit awkward with all these arrows, but the 3 we're going to use to create a multiplication equation times, remember we're doing multiplication, the opposite of division. We don't know this number. That would be the number that goes up here. So I'm going to use a variable or a letter to represent what we don't know. And then we're looking to get 24. Well, 3 times 8 is equal to 24. I want to use both these numbers. And again, let me show you on a multiplication chart, which you can use a chart for our class and for this lesson. So I would go to my 3 facts. And when I count down 1, 2, 3, 4, 5, 6, 7, 8, it took me 8 groups of 3 to get to 24. That's why I have an 8 here. Now remember, we're going to use both these numbers. That's why I'm circling it. Please pay attention to that step. The 8 goes on top, and the 24 goes on the bottom. Notice that when I subtract, the numbers are the same. So in this case, there were no remainders. Again, where did I get this 24? I just used my division fact to write my multiplication fact. Now, we're going to do a problem with remainders. 25 divided by 3. I'm going to use my division fact to build my multiplication fact. So here's my 3 times opposite, right? We're going opposite of division is multiplication. 3 times n is the unknown number, is equal to 25. And again, I'm going to draw it like that. Well, we know from the up here that the closest I can get is 24. Now you say, well, isn't there a 25? Well, let's check. If I look For equal groups of 3 or multiples of 3, notice we don't see a 25 here. The closest I can get without going over 25, right, is right here, is 24. So that was 8. But it did not equal 25. I'm going to scratch that, and instead I'm going to write it actually equals 24. Notice that I circled both numbers, the 8 and the 24. This 8 goes on top up here, and this 24 goes down here. But notice this time, instead of it being the same, it's not the same. It's different. Remember in math, different or difference means that you subtract. 5 take away 4 is 1. So our answer is 8 with a remainder of 1. Let's solve some more. 44 divided by 6. I'm going to use my 6 in the 44 to create a multiplication. 6 times n is equal to 44. I know that on my multiplication chart, and to save time, I'm not going to use the chart anymore. 6 times n would be 7. But 6 times 7 does not equal 44, but it's as close as I can get without going over. It actually equals 42. So I'm going to cross off the 44. What am I going to do? Am I just going to use one of these numbers, or am I going to use both? Remember, I'm using both. The 7, or the smaller number, goes on top, and the 42, the larger number, goes on the bottom. And you'll notice that they are different. 44 is different from 42. How different? Well, we subtract. So in this case, it's 2. Our answer is 7 with a remainder of 2. 20 divided by 3. 3 times n equals 20. If you use your facts, that would be, if you use your multiplication facts, that would be 3 times 6, but it does not equal 20. It equals 18. Remember, we're going to circle and use both. 6, 18 on the bottom. If I subtract, I get 2. So my answer would be 6 with a remainder of 2. I like to write it up here. The reason why is that sometimes when students write the R, if you're not really neat at writing, it may look like another digit, and it'll look like 62 or 612. So I usually like to put it up. That's not a rule, though. You can write it down on the bottom, but try to make it clear that that is a R, stands for remainder. The R that's supposed to be an R, okay? And 6, you would read this as 6 remainder 2. 53 divided by 8. Again, if you want to pause, you can. 8 times n equals 53. Again, I'm just using my facts from the division to create my multiplication. I know that 8 times 6 does not equal 53. It equals 48, but that is the closest I can get to 53 without going over. So it's not 53. It's actually 48. I circle both and I use both. The 6 on top. And now I subtract. Technically, I guess we could regroup. I just see this as, as 5. But the answer would be 53 divided by 8 is equal to 6 groups, but it has a remainder of 5. 76 divided by 9, I'm going to use my 9 and 76. So 9 times n equals 76. I know from my multiplication facts that I cannot multiply 9 by any number and get 76. But the closest I can get is if I multiply it by 8, I can get to 72 without going over. So it's not 76. It's 72. Remember, circle both numbers as a reminder that we're using both numbers. And then use both. Find the difference, and the answer is 8 with a remainder of 4. One or two more. 55 divided by 6. If you want to pause, go ahead and solve. I'm going to use my division problem to create a multiplication equation. 6 times my unknown number, which I'm calling n, is equal to my 55. I know that if I multiply 6 times 9, that'll get me really, really close, but it's still not 55. So I'm going to scratch 55. It's actually 54, which is close. So circle both, please. The 9 goes on the top. And the 54, notice they are not the same. They're different. And remember, in math, different or difference means you subtract. So our answer is 9 with a remainder of 1. One more. Let's try a word problem. There are 38 water bottles left in a box. The water needs to last for an entire week. If the same amount of bottles are used each day, then how many water bottles are there for each day? Okay. So let's see, there's 38 water bottles that are in a box. The water needs to last for an entire week. It's the same amount. So that's a clue that this is either multiplication or division. And again, each day, because remember we said that division is fair share, equal groups. So the word same and each imply that it's fair share. Then how many water bottles? I notice there's not a number here. So let me see again. 38. The water needs to last for a week. Well, I know that a week is 7 days, right? So my problem here is going to be, I'm starting out with my total, by the way. It's telling me how many are left. It's not saying that, I'm using 2 bottles a day, and if you go 7 days, it's telling me what I have left. So this problem is 38 divided by 7. I'm going to use multiplication to solve. I'm going to use my 7. Times my, remember, this number is what we're looking for. That's unknown right now. And that is in this spot. The n is called a variable. It's our unknown value. And we know that we want to equal 38. That's what we're shooting for. Well, I use my knowledge of multiplication. In this case, I'll use my chart. And you're going to see when I look at the 7, do you see a 38 here? No. I have to get as close to 38 as I can without going over. This is too far, so it's going to be the 35. If you count 1, 2, 3, 4, 5. So in other words, 7 times 5, but it's not equal to 38. We said that that was actually equal to 35. I'm going to write right up here. So it's not 38. It's actually 35. I need both of these numbers. The 5 goes up here. And the 35, and I see when I compare it, they are not the same. They're different, and different means subtract in math. So my answer is going to be 5 So there are five. In other words, how many bottles are there for each day? There's five for the week. Every day there's five. But at the end of the week, apparently, there would be three left over. All right, everybody. Thanks a lot. We'll see you later.